In an earlier video on YouTube, I was talking about the LM386, and this is the extra loudspeaker box that I've made, connected to the headphone output here. And well, let's first listen to the headphone sound. Of course, I have to go to a radio station, say here. Well, that's the bad thing of this program. Sometimes the cursor jumps away. Anyway, no problem. Well, now it's okay. And this is what we hear. It's typical American, I think. Anyway, 13.628 megahertz. Tuner here. So, tune the antenna a little bit, but the focus is now on my extra external amplifier. So, plug it in, and now we are listening to this external amplifier. The question is always, does it work better? Is there more, is the sound or the music, not the music, especially the sound, better intelligible? And I've used here a 50K potentiometer. The datasheet that I've showed in the earlier video tells us that we need a 10K potentiometer, so 10,000 ohms. I was a little bit stubborn anyway, and indeed I needed here a small voltage divider 47K trim potentiometer to lift the signal to the LM386 a little bit down. It's now halfway, say halfway, not halfway, but anyway, and I mean not perfectly halfway. That means that in this case a few problems were solved. At first, the extreme sensitivity at the input of the LM386 that led to oscillations. When the volume control here, this one, the volume control, was on its minimum position, the whole circuit started to oscillate. Could have to do with all kinds of things that are here in this situation. I don't want to focus too much on that. When I turned the potentiometer down, completely down, it oscillated. When I turned it a little bit up, here for instance, so it worked. At first it was not oscillating, so my idea was, let me mount here at one of the electrodes of the potmeter at 1K resistor. That worked a little bit anyway. Finally, say the good solution was to use this voltage divider at the input that brings down the input level of the output of the computer, the headphone output, to a good input level. And that's more or less always when you are doing radio experiments, especially audio experiments. Say the correct level that has to be sent into a circuit, be it an audio amplifier, be it a high frequency amplifier. The level is always very important. There must never be a kind of overdrive, and the input of an amplifier must also have a certain impedance. And then I mean regarding to audio, and we are looking here to audio, the impedance must be more or less somewhat low. Otherwise, like I tell here, I was a little bit stubborn, the circuit can start to oscillate, etc., etc. much more about that in my book, Schematics 2. I will give the link in the text box. Anyway, what have I done? I've also made here a kind of simple noise reduction. Noise reduction can be done in a very easy way by, say, mounting a capacitor in the order of 10 nanofarad up to, in this case, 470 nanofarad from the signal line to ground. The bad thing of that idea is that there is no, say, certain bandwidth. All the frequencies from, say, 8000 Hertz, perhaps even 5000 Hertz, are damped off, and that means that such a kind of filter is more or less not critical. It doesn't have a bandwidth. So, anyway, well, only the lower frequencies pass, and everything above, say, 5000 Hertz or so is more or less dropped down. I will show that. Well, now, well, my receiver jumped again, or the radio station jumped away. Let's try. Well, now I lifted the level of the volume control. And the noise reduction is switched on. And this is the effect when the noise reduction is switched off. So the problem of oscillation is gone now. And there's also, say, a kind of problem of this chip, the LM386. Its output level is 0.5 watt. In fact, that is too low for such an application. You need, for, say, such a unit, external audio unit for a shortwave receiver, you need minimum, say, 1 watt or 2 watt, because when the filter does its work, and then especially a band filter that has a certain shape, cutting down the frequencies below, say, 300 Hertz and say 4 kilohertz, you need more amplification and to make the sound properly intelligible, and you need less noise. So the signal by itself is quite noisy, and also the amplifier in such a case, in the ideal case, that's what I mean, needs in more or less a very good and proper precise noise reduction to receive, say, in a good way all these radio stations on shortwave. So that will be a next project. This will work as long as it goes. I don't publish the schematic. I think it's not ideal. The first schematic that I showed was okay for that application anyway. This is noise reduction. And of course we have to do with fading now. It's now 13 megahertz band. Fading is plays always a very big role. The received signal goes up and down, sometimes during a few seconds, sometimes during 1 or 2 seconds or so, but this is more or less slow fading, and there is of course an extra slow fading that goes very, very slowly. Within, say, 1 minute or so, you don't receive a radio station, and then after 1 minute you receive it again anyway. So it works a little bit. And here, perhaps it's also important to tell, when you directly listen to the speaker, you hear, you have a better intelligibility. Let me show it again.
And I think also, in a way, it's important to stabilize the housing market. So yes, we need to understand the tariff potential. It's not to preclude any of the big corrections and
And
adjustments.
when I close this, certain frequencies in the higher range say are damped by this aluminum plate. So in fact I need here a hole and a piece of cloth. Of course that cloth must also be transparent for higher frequencies. It must not damp, say, the sound. Anyway. So a lot to tell. Thanks for watching. I hope to do more experiments and especially make an audio amplifier that works better.